An octopus has 3 hearts and bright blue blood. Here is the strange reason evolution needed so many pumps. Reach into a tide pool and pull out an octopus, and you are holding one of the strangest circulatory systems on Earth. It has 3 hearts. Its blood is not red, it is bright blue. And if it tries to swim too hard, its main heart simply stops beating. This is not a glitch. It is the direct result of a chemical choice octopuses made hundreds of millions of years ago when their blood swapped iron for copper. That one swap cooled their metabolism, shaped their body plan, and forced them to grow extra pumps just to stay alive. The 3 hearts do not all do the same job. 2 of them are called branchial hearts. They sit at the base of the gills, one on each side, and their only job is to push dark, oxygen-poor blood through the gill tissue so it can pick up oxygen. The 3rd heart is the systemic heart. It sits in the middle of the body and handles the bigger job, pumping the freshly oxygenated blood out to the muscles, the arms, the brain, and the skin. Think of it like a relay race. The branchial hearts refill the tank. The systemic heart delivers the fuel. Without that relay, an octopus literally cannot move oxygen through its body fast enough to stay alive. Your blood is red because it carries oxygen on a molecule called hemoglobin, which uses iron. Octopus blood uses a different molecule called hemocyanin, which uses copper instead. When copper binds to oxygen, it turns bright blue. Copper hemocyanin has a huge advantage in the deep ocean. It works well in cold water and in low oxygen conditions where hemoglobin would struggle. But it comes with a catch. Hemocyanin carries only about 1/4 as much oxygen per unit of blood as human hemoglobin does. To make up for that, octopuses need much higher blood pressure and much more pumping power. 1 heart simply is not enough. That is the core reason evolution bolted on 2 extra pumps, 1 for each gill. Here is the part that sounds impossible. When an octopus pushes water through its siphon and jets forward to swim, its systemic heart stops beating. Scientists have filmed it. The main heart pauses for several seconds every time the octopus jets, because the muscular contraction needed for jet propulsion squeezes the heart and interrupts its rhythm. Swimming this way is exhausting. A study published in the Journal of Experimental Biology showed that oxygen debt builds up within minutes, and octopuses need long recovery periods after even short swims. This is why octopuses almost always prefer to crawl across the seafloor on their arms. Crawling uses less oxygen, does not pause the heart, and lets their inefficient blue blood keep up with demand. Three hearts and blue blood shape almost everything about an octopus. They live in cold, oxygen-rich water because warm water holds less oxygen and their blood is already struggling. They are short-lived, usually only 1 to 2 years, because a copper-based circulatory system running at high pressure wears out fast. They are ambush predators rather than endurance hunters because long chases are metabolically impossible. And most of their nervous system, about 2/3 of their 500 million neurons, sits in their arms rather than their brain, which reduces how much oxygen the central body needs. 3 hearts is not an upgrade over 1 heart. It is the bare minimum an octopus needs to survive with the blood that evolution gave it. If you found this fascinating, subscribe to Curious Science. Next time, we explore why you get food poisoning.